Good afternoon, friends. This lecture is on waves. What is a wave? How waves are formed? So, first, we will see the definition. Wave is a disturbance which travels through the medium without carrying the medium along with it. In this pic, you can see these are the waves. So, when a drummer beats a drum, its sound is heard at distinct places. You can listen in the video. Here is the sound. So the disturbance is the pressure variation in the medium. I am now changing the amplitude and frequency. So as the amplitude increases, you can see the variation. Now I am going to increase the frequency. So the air itself does not move, just it is the pressure variation that is responsible to hear the sound. So a wave which is traveling along a rope whose one end is fixed as shown in this video and other end is moved up and down is an example of one-dimensional wave. You can see this side it is up and down and this side it is fixed. So now you can see in the form of pulse how the wave propagates. So now if we see the other end is loose, then wave propagation is like this. In the oscillation it is like this, you can see. So in the slow motion we can see very clearly how the wave is propagating, and now we had fixed the other end. In the slow motion you can see the clear change. So now I am restarting the simulation again in the slow motion in the oscillation mode with the fixed end. So now as we increase the amplitude, you can see this is the increase in amplitude. So from the reference line to this maximum value is the amplitude. So you can see the value of amplitude 0.97 centimeter. Now I am changing the frequency. So this is 2.32 hertz. Now amplitude is further increased, you can see. Now if we decrease, then this is, I think you can clearly see what is the amplitude and what is the frequency and how these two parameters influence the wave. So this wave is one-dimensional wave. So when a butter drop is thrown into still water of a pond, ripples are produced. You can see in this video there are water ripples. These ripples are the disturbance of water molecules. So this is just the way to transport the energy from the origin to the other end. In this case water molecules are oscillating but they are not propagating. Wave is propagating. So that means when water drop is thrown into still water of a pond, ripples are produced which spread out slowly outward. You can see in the top view, you can see in the slide view. So these are the water waves. So, which spreads out slowly outward in ever widening circles. As you can see in the video, water particles do not travel along with the wave but vibrate only up and down about their equilibrium position. So we can identify the motion with the help of crest and trough. You can see that crest and trough traveling from the center of the disturbance. So these type of waves are two-dimensional in nature. Then we can see when we switch on the light, the electromagnetic radiation, that means visible light, you can see there is the lamp. When it burns, then we can see the light. So this light wave is called electromagnetic wave. When a point source of light emit light waves in all directions which spread out uniformly in the form of ever increasing concentric sphere with the velocity 3 into 10 raised to 8 meter per second. So these waves are three-dimensional. So in this case, the self-generating electric and magnetic fields which are oscillating in phase with each other, and there is no need a medium to propagate the electromagnetic radiations. So we have different examples. For example, sound wave, water wave, these are the type of mechanical waves, and electromagnetic waves. In electromagnetic waves, visible light, radio wave, microwave, X-rays, gamma rays are the example. And in matter wave, atomic particles possess wave properties under certain conditions. So similarly, we have gravitational waves. Gravitational waves, the disturbance in the curvature of the space-time generated by accelerated mass that propagate as wave outward from their source at the speed of light. So the bodies like galaxies, stars, they produce gravitational waves and interact with each other with the help of these waves. Then we have few characteristics of the wave. First is time period. So it is the time taken by a complete cycle if the wave to pass a point. Then wavelength is the distance between corresponding points, such as two successive crests or such as between two successive troughs, is called the wavelength. Then amplitude is the maximum displacement in the waveform. Then velocity each time the source of disturbance vibrates once, the wave moves forward at a distance lambda, that is equal to wavelength. If there is new vibrations in 1 second, the wave moves forward at a distance of nu into lambda. So this is nu upon t, but this tt is time period. So the distance that the wave moves in 1 second is the velocity of the wave, that is v equal to nu into lambda or lambda upon t. Similarly, another characteristic is the intensity, the energy transferred on an average by a wave in unit time through a unit area perpendicular to its propagation direction is known as the intensity of the wave, and mathematically intensity is equal to square of amplitude. So thank you.